Okay. Hello guys, welcome to the lesson of DBA from Introduction to Practice. I'm your old friend 𝗕𝗀𝗲, the global technical evangelist for OceanBase. Today, we will continue the second part of using the OceanBase Community Edition for business development. Let's get started. Let's first introduce the development through ODC graphical development tool. Okay, let's first look at what ODC is. ODC is OceanBase Developer Center. It's a database graphical development tool and a collaborative platform for data research and development, and also production change management. It has two product forms, desktop version and the web version. The web version of ODC supports two deployment forms, single node and high availability. ODC web version also provides two working modes, personal space and team space. Personal space is designed for individual developers, offering a desktop-like experience in the browser. It allows you to access and create data source freely using the platform's tool for database development. Team space is ideal for collaborative work between developers and DBA, serving as both a develop tools and a management platform. ODC provides one-stop database development and control with features like project collaboration, stable changes, data security, and hot code data separation. The ODC desktop version is lightweight, easy to deploy database development tool compatible with Windows, Mac, and Linux. The web version combines development tools with management and collaboration features, emphasizing the security and efficiency of database changes. We recommend the web version of ODC as the first choice. Here is the panoramic view of ODC functions. First of all, from the user level, whether the user is doing DBA, app development, data analysis, or business operation, ODC can be used. In addition to SQL development, ODC also provides management and control coordination. SQL development includes SQL execution, PL lifecycle, object management, perform analysis, data generation, and others. Management and control coordination includes access rights, change control, data lifecycle management, and others. At the same time, ODC supports data sources. In addition to OceanBase, also supports MySQL. This page briefly introduces the data source supported by ODC and the corresponding version. For specific ODC function limitation, you can refer to the official website. Next, let's look at how to use ODC. First, deploy ODC. Before deploying ODC, there are some environmental requirements. First one is the metadatabase. Before installing the web version of ODC, you need to prepare a metadatabase. The metadatabase of the desktop version of ODC is local and will be automatically created when used for the first time. So there is no need to manually prepare the metadata. The character set of metadatabase must be UTF-8 The second one is install Docker. In addition, we also have a recommended value for ODC's resource requirements, such as CPU, memory, and others, which is shown in the table below. Next is the specific development requirements of ODC. Here we compare the web version of OTC and the desktop version of OTC. And you can see that there are still many differences. And I trust that you can review this part after this lesson. Next, let's look at the specific process of deploying the web version of OTC. The first step is to install an OceanBase database as the metadatabase of OTC. The second step is to download the image file of OTC. The third step is to load the image file, and then run the image. You can also check the detailed information on the OTC official website. After the OTC is deployed, you can access the OTC through a browser. The access address is IP plus port. The default port is 8989. This feature is a login interface of OTC. After logging to OTC, you can first select your workspace, which can be a team space or a personal space. Generally, in the production environment of an enterprise, a team space is used. In addition to the workspace, you can create a new project and add a data source, check OTC users, security items, and others. Next, let's look at the basic development interface. You can select a database and click log on to the database to enter the development interface of this database. We will introduce how to develop in the interface in detail later. When we use OTC, a very important part is data source. What is data source? A data source refers to a remote database environment, such as an independently deployed OceanBase cluster or other database system instance. When we use OTC, we first need to add a data source. Each data source can contain many databases, and a project can contain multiple data sources. Here, we show you how to add a data source. The required data source information includes IP, port, username, and password, and others. If the data source is OceanBase, then cluster name and tenant name are also required. After we add a data source, we can add a specific database to this data source. After creating the database, we can assign the database to the project. We can see which sessions are currently connected to the data source from the session column. In our production environment, we will also use the functions of the 𝗕𝗂𝗶 and command line window. 𝗕𝗂𝗶 is used to store deleted tables, views, and other database objects. And we can also empty the 𝗕𝗂𝗶 or delete a specific object in the 𝗕𝗂𝗶 permanently. Please note that this feature is tenant level. Please enable it with caution, because the 𝗕𝗂𝗶 will also occupy some storage resources. Another function is the command line window, which is the 𝗕𝗂𝗶𝗁 tool. We can directly enter the 𝗕𝗂 commands here. 𝗕𝗂 development mainly includes two aspects. One is database development. The other is database management. In database development, including execution plans, details, time, records, and others. In database management, it mainly includes tables, views, PL objects, and others. When we edit 𝗕𝗀𝗀, it also has syntax highlighting, smart prompts, 𝗕𝗀𝗀 checking, and other functions to help us. After we finish writing the 𝗕𝗀𝗀, we can also save it as a 𝗕𝗀𝗀 script, which is convenient for us to use directly next time. After we execute 𝗕𝗀𝗀, we can do some data replication and data viewing and data editing and other operations. And we can also directly export the result set. Next, I will give a detailed introduction and a demonstration of the following functions. The first one is syntax highlighting, code hinting, and 𝗕𝗀𝗀 checking. The second one is 𝗕𝗀𝗀 script. And the last one is the result set display. Let's first look at the syntax highlighting feature. After we finish writing a 𝗕𝗀𝗀 statement, just click the Format button, and it will automatically format the 𝗕𝗀𝗀 statement. At the same time, we can see that the keywords in the 𝗕𝗀𝗀 statement will be highlighted, such as select, from, where. Next is the syntax prompt function. From the left three pictures, we can see that when we enter 𝗕𝗀𝗀 keywords, database object name and column name, prompts will appear. These tips will help us avoid writing wrong keywords and quickly write some complex table names. Next is 𝗕𝗀𝗀 check. First, we have a security specification setting, which says some rules by default, such as tables cannot use foreign keys, columns must have comments, and others. User can choose whether to enable these rules. After we finish writing a 𝗕𝗀𝗀 statement, we can click the 𝗕𝗀𝗀 check button, which can display the problems in the 𝗕𝗀𝗀 statement. Next is the demonstration of the 𝗕𝗀𝗀 script function. In the daily work of DBA, certain 𝗕𝗀𝗀 scripts are often used repeatedly. To save time and avoid rewriting them each time, we can store these frequently used scripts or code snips for easy access in the future. Next is the display of the result set. And we can also export the result set or convert it to a CSV file, even the 𝗕𝗀𝗀 file. When we display the result set, if the amount of data in a column is especially large, we can display the data in column mode, so that the user can have a better view of the data. If the user has large fields data in the table, it can be displayed in text, hexadecimal, or image mode, allowing user to restore the true appearance of the data. After querying the result set, we can also edit and export the result set. We can edit the selected row and modify it. And ODC also supports multi-row modification and one-click sublimation. We can also export the result set. And ODC supports multiple formats, such as CSV, Excel, and 𝗕𝗀𝗀. After we execute 𝗕𝗀𝗀, if we found the 𝗕𝗀𝗀 execution time is very long, or we want to view the 𝗕𝗀𝗀 execution process, we can view the 𝗕𝗀𝗀 execution plan and 𝗕𝗀𝗀 and SQL execution time statistics in OTC. This feature shows the full link diagnosis of the execution plan. You can check the time taken for each step in the execution plan, which is convenient for you to troubleshoot problems. The functions mentioned above are related to database development. In addition, ODC also has object management functions. Database objects include tables, views, functions, stored procedures, packages, triggers, and others. ODC provides various database object management operations, including basic operations such as adding, deleting, modifying, querying, and some special operations. For detailed management functions, you can refer to the official website. Compared with other development tools, what are the advantages of ODC? We will briefly introduce it from the following three aspects: product forms, tool orientation, management, and control coordination. Regarding product form, ODC is the only free open source development platform on the market that integrates the database development, management, and control coordination capabilities. Yeah, it's the only one. On the tool orientation aspect, ODC tool interaction focus on easy of use, and ODC tool capabilities currently cover 90% of common customer scenarios. On the last aspect management and control coordination, ODC combines the work concept of integrated development, maintenance, and takes projects as the core for management and control coordination. Let's introduce the last part of this lesson: horizontal split using OceanBase partition table. In OceanBase, partitioning means breaking a table into multiple smaller and more manageable parts according to certain rules. Each partition is an independent object with its name and optional storage feature. For application accessing the database, there is only one table or one index in the logical sense. However, in practice, a table may consist of dozens of physical partition objects, each functioning as an independent object that can be accessed individually or as part of an entire table. Partitions are completely transparent to the application and do not affect the business logic of the application. And one schema object exists from the application perspective. Accessing partitioned tables does not require modifying SQL statements. Partitioning is very useful for many different types of database applications, especially those handling large amounts of data. What are the benefits of using partition tables? The first one is improved usability. A partition being unavailable doesn't mean that the object is unavailable. The query optimizer automatically remove unreferenced partitions from the query plan. Therefore, queries are not affected when a partition is unavailable. The next one is easier object management. Partition objects has fragments that can be managed collectively or individually or individually. DDL statements can operate on partitions instead of entire tables or indexes. Therefore, resource-intensive tasks such as rebuilding indexes or tables can be broken down. Next is reducing contention for shared resources in OLTP systems. The fourth one is improving query performance in data warehouses. In the AP scenario, partitioning can be speed up the processing of instant queries. Partition keys have a natural filtering function. The last one is provide better load balancing effect. The storage unit and the load balancing unit of the OceanBase database are partitions. Different partitions can be stored on different nodes. Therefore, a partition table can distribute different partitions on different nodes, so that the data of the table can be distributed more evenly across the entire cluster. Next, let's look at the precautions when creating a partition table. If the amount of data is large and the access is constrained, you can use a partition table when creating the table. Generally, partitioning can be considered for data volumes about 10 million. And the upper limit of the number of partitions is 8,192. And generally, in the production environment, the number of partitions is at most dozens or hundreds. Partition table constraint has some considerations. When creating a partitioned table, at least one field corresponding to each primary key and unique key on the table must be included in the partition key field of the table. If the table doesn't have a primary key or unique key, the partition key can be any field. It's recommended that global uniqueness in the partition table can be achieved through the primary key, if it can be achieved through the primary key. The unique index of a partitioned table must include the split key of the table partition. Regarding the partition strategy, it's recommended to design it based on the actual purpose and the application scenarios of the table. Regarding the selection of partition keys when using partition tables, you should choose appropriate split keys and split strategies. For example, we have the following partition strategies: 𝗕𝗂𝗶𝗴 partition, range column partition, list partition, list column partition, key partition, combined partition. Combined partition is a combination of the previous partition strategy. For range partition, it's not recommended to set the last column to max value, and 𝗕𝗂𝗶𝗴 partition is not suitable to perform range queries based on partition fields. The partition table of the OceanBase database is built-in function. You only need to specify the partition strategy and the number of partitions when creating the table. The query cycle of the partition table is the same as that of the ordinary table. OceanBase's 𝗕𝗶𝗴 or OB server will automatically route the user cycle to the corresponding node. Therefore, the partition details of the partition table are transparent to the business. If you know the partition number of the data you want to read, you can directly access the partition of the partition table through 𝗕𝗂𝗁. Here are some examples showing us how to access a specific partition of a partitioned table. Let's briefly introduce the range partition. Range partition maps data to the corresponding partition according to the partition key value. A value range is established for each partition when the partition table is defined. It's common partition type and is often used with data type. For example, a business log table can be partitioned by day, or week, or month. On the right side is the syntax of range partition. We also listed an example of range partition. For range partition rules, you can review them after this lesson. And we need to note that the first one, range partition can add and delete partitions. If the last range partition specifies max value, no new partitions can be added. Therefore, it's recommended not to use max value to define the last partition. The second one, range partition requires that the result of the table split key expression must be an integer. Next, let's introduce the range columns partitions. The difference between range columns and range is that the first one, range columns partitions do not require int type, but can be of any type. And the second one, range columns partition cannot contain expressions. The last one, range columns partitions support vectors. For the syntax and example of range column partitions, you can review them after this lesson. The next is list partition. List partition are divided according to the value of the enumeration type and are mainly used for enumeration types. The partition key can be a column name or an expression. The partition key must be an int type or an expression that returns an int type. A partition expression can only reference one column and cannot have multiple columns. List columns partitions is an extension of list partition. It supports multiple partition keys and supports int data, data type, and data type. There are some differences between list columns and the list. List columns partitions do not require int type, but can be of any type. Expressions cannot be written in list columns partitions. And list column partitions support vectors. Next, let's briefly introduce 𝗕𝗂𝗁𝗲 partition. 𝗕𝗲𝗁𝗲 partitions is suitable for scenarios where the range partition and the list partition method cannot be used. The implementation method of 𝗕𝗁𝗲 partition is simple. By hashing the value of the 𝗕𝗁𝗲 function on the partition key and recording it in different partitions. Usually used for point queries with a given partition key, such as partition by user ID. 𝗕𝗁𝗲 partitions can usually eliminate hard support queries. The following are the rules of 𝗕𝗀𝗃 partitioning. The first one, the partition key is int type, or an expression that returns int type. The next, vectors such as partition by 𝗕𝗃 C1, C2 cannot be written. The next one is, if the partition name is not specified when creating 𝗕𝗃 partitions, the partition is named by the system according to the name rules. The last one, 𝗕𝗃 partition do not support adding or deleting partitions. Key partitioning is similar to 𝗕𝗃 partitioning. It also determines which partitions the data belongs to by taking the mode of the partition's number. The system will perform an internal default 𝗕𝗃 function as the key partition key and then kick the mode. Maybe users cannot know which partition a row belongs to, so simple calculations. Key partitions do not require int type, and they can be any type. Key partitions cannot be written as an expressions, only columns. Key partitions support vectors. At least, we need to note that when key partition's key does not write any columns, it means that the column of the key partition is the primary key. Compound partitioning provides the advantage of two-dimensional partitioning. Two-dimensional partitioning means splitting data into partitions according to 2 dimensions. OceanBase MySQL mode currently supports 6 partition types: 𝗕𝗃, range, list, key, range columns, and list columns. Two-dimensional partitions is a combination of any 2 partitions type. You could have a question: what are the advantages of compound partitioning? The first one, depending on the SQL statement, partition pruning on 1 or 2 dimensions may improve performance. And the next one, queries may use full partitions or partial partitions joined on either dimensions. The next one, you can perform parallel backups and restores on a single table. And the first one, the number of partitions is greater than a single level of partition, which may benefit from parallel execution. The last one, you can store data differently based on the identity of the partition key. Although OceanBase supports range plus 𝗕𝗃 and 𝗕𝗃 plus range combinations in compound partitioning, the add or drop operation of range partitioning must use range partitioning as the first level partitioning method. Therefore, it's recommended to use the range plus 𝗕𝗃 combination for easy maintenance. On the right side is an example of using the range of 𝗕𝗃 combination partitions. After the partition table is created successfully, you can modify the partition rules, add partitions, delete partitions, and truncate partitions according to business needs. For specific syntax, please refer to the official website. Next, let's briefly introduce indexes, which will be introduced in detail in the next lesson. Partitioned tables can also be indexed to improve performance. Like partitioned tables, indexes on partitioned tables can be partitioned or non-partitioned. If the index of a partitioned table is not partitioned, it's a global index. If the index partition of the partition table can be divided into two categories according to the partition strategy. One type is a partition strategy that is consistent with the partition table. The index is also called a local index. The other type is a global index whose partition strategy is inconsistent with the partition table. When creating an index for partition table, a local index is created by default. It's recommended to use local indexes as much as possible, and use global indexes only when necessary. Let's briefly introduce several usage recommendations. The first one, partitioning is done based on business rules. The next, regarding the selection of partition keys in multiple dimensional business query scenarios, if both account numbers and card numbers exist, the selection of partition keys should be considered based on business usage frequency and business importance. The next, partition planning should align with clear business scenarios and query conditions to leverage partition pruning for better query efficiency. Avoid arbitrary partitioning when scenarios are unclear. If query conditions only align with first-level partitions, it's best to stick with first-level partitioning without forcing second-level plans. The first one, for index creation of partitioned tables, select in the order of local index to global partition index to global index. The global index only used when necessary, because the global index will reduce the performance of DML and may generate distributed transactions. The next one, try to bring partitions keys when querying or modifying partition tables. The next one, is not recommended to specify max value for range partitions. Otherwise, new partitions cannot be added later. The next, to avoid right amplification problems, when selecting a custom primary key for a table, do not use randomly generated values. Try to keep them in order, such as increasing in time. For tables with horizontal data cleanup, for tables with historical data cleanup, partition table design needs to be based on business usage scenarios and cleanup cycle. For example, for transaction flow tables, partitions can be created by day, and old partitions can be deleted by day. Okay, if you have any questions, now is the perfect time to ask. Okay, let me check the Q&A channel. Okay, do you have any questions? Okay, no questions. Before we wrap up, I'd like to remind you that our next lesson will be next Monday evening, where we will be covering OceanBase's extended functions and their MySQL tenants. We look forward to seeing you then. You can also reach out anytime through our OceanBase GitHub and select community for further assistance. We are always here to help. We will be sharing how you can access the course materials and today's presentation slides in the comments section of this video. All the resources are free, Don't forget to subscribe to our OceanBase YouTube channel and join our community to stay up to date and get involved with us. See you guys. Bye bye. Okay.